Most blockchains track value the way a spreadsheet tracks numbers, one giant table of balances keyed by address. SUI flips that model on its head. Every coin, every sword in a game, even the internal state of a DIO proposal is packaged as an object with its own globally unique ID. An object also carries its current owner and, if relevant, the rules that govern it. Because the chain treats each object as a self-contained parcel, transferring ownership is literally a pointer swap. The owner field changes and consensus moves on. Objects come in three flavors. Owned objects belong to one address. Shared objects act like public bulletin boards. Immutable objects lock forever after creation. That simple taxonomy eliminates an entire category of double-spend races that haunt account balance architectures. With objects neatly siloed, SUI's execution engine can treat many transactions like ships in separate lanes. If Alice moves coin number 88 and Bob upgrades badge number 7, those writes concern disjoint storage, so validator threads finalize both at once. Only when two transactions touch the same shared object, say they both append to a marketplace order book, does SUI grab a brief exclusive lock. Readers may still access a shared object's previous version, but just one writer gets the green light per block. This deterministic scheduling allows horizontal scaling without speculative rollbacks. Real-world benchmarks routinely cross 100,000 transactions per second, while a plain owned object transfer reaches finality in less time than it takes your phone screen to refresh. Classic BFT protocols intertwine two chores, spreading each transaction to every honest validator and agreeing on a final order. SUI teases those chores apart. Narwhal handles the gossip pipeline. It batches user payloads into a DAG, making sure everyone sees the identical inventory without caring about order. Once data availability is guaranteed, Tusk steps in to vote on an ordering of the DAG's frontier. This decoupling yields two benefits. First, slow or temporarily offline nodes can catch up to the DAG without stalling the ordering stage. Second, engineers can evolve or replace either layer independently. Upgrade Tusk's voting rules or swap in a new networking codec for Narwhal without re-auditing the whole stack. The end user simply experiences predictable throughput and instant finality. SUI makes you prepay for two resources, CPU time right now and disk space forever. The compute slice is familiar. You buy validator effort in microseconds. The second slice is a storage deposit that lands in a global fund. If later you delete an NFT or compress a vector field, the chain measures the freed bytes and automatically refunds the corresponding deposit, plus a prorated share of staking rewards the fund earned while it held your collateral. This feedback loop incentivizes lean data models and prevents long-term state bloat from choking future validators. It also flattens fee volatility. Routine transfers rarely compete in a gas auction because disk space is prepaid and predictable. Day 1 DX matters as much as protocol science, and SUI's toolchain feels pleasantly modern. Type SUI start, and a 4-node validator cluster spins up locally. Faucets, dashboards, Explorer UI, the works. The VS Code extension highlights syntax, auto-formats modules, and even surfaces move proper diagnostics inline. Prefer scripting? Reach for the official TypeScript, Rust, or Python SDKs. All expose identical high-level calls for signing, object inspection, and parallelized batch submission. The crown jewel is the scenario test harness. Within pure move code, you create test wallets, mint objects, fire transactions, and assert on final state. No JavaScript harness, no flaky RPC calls. Tight feedback loops mean bugs rarely survive until DevNay. The object model you've just met already powers dozens of live projects. DeFi decks with near zero slippage, 3D games whose items are first-class objects, and crucial for Web 2 brands, loyalty systems that a user can claim with nothing more exotic than an email account thanks to SUI's ZK login feature. Our capstone project, SUI Pals, purposefully mirrors that landscape. In the next module, you will mint a fungible loyalty token. Later, you will convert points into a non-transferable badge to curb bots. Finally, you will launch a shared marketplace where badges unlock community perks. Every new concept will snap into this single evolving repo so your learning curve feels like steady, cumulative progress. Time to materialize those ideas. Welcome Badge is our very first on-chain object. The key ability tells SUI this struct deserves a globally routable identity. Store lets us embed it inside other structs later. In claim, we ask object.newCTTX for a never-before-seen UID, stamp the caller's address and the current epoch for provenance, then transfer the badge to its rightful owner. Notice there is no array index, no ledger row. Ownership is an intrinsic field. Two users can call claim in the same block without conflict because each badge is a separate object. Compile this module with SUI move build. Run SUI client call -- function claim on DevNet and watch a brand new badge land in your wallet.